Hello everyone, welcome back to Diksha Karnataka YouTube channel, and you are watching your favorite KCET 2026 series, that is Sankalp KCET 2026. And today I am going to discuss the most important part of any chapter, that is the PYQs of KCET. So wave optics, we have already completed the theory in two parts, and today I am going to cover the KCET PYQs for this chapter. And if you want to download the PDFs of this lecture and all the lectures that we have already done, then don't forget to join our WhatsApp channel. And if you are watching our videos for the first time, I request you to subscribe to our channel. Don't forget it, so that you don't miss out on any updates, any videos that we are doing for your PUC as well as KCET journey. Now let's start. Before starting, I just want to show you that those who have followed our instructions and obeyed everything that we are saying, followed our lectures and attend the classes, their pictures are here along with their ranks. As you can see, outstanding ranks are there, and lot many more are here as well. And next year, well, it might be you with your picture and your name over here. So if you are following us from the beginning, then definitely you have a very high chance of scoring rank below 1000, which is our dream. Now let's start with today's journey. It is questions from 2025, slightly odd, so that's why I was discussing the shape of the wavefront. If you remember, if AB is incident plane wavefront, then the refracted wavefront in N2 greater than N1. So here is the plane wavefront which is falling on it. N1 is the refractive index of the medium, and N2 is the refractive index of the lens. And also it is mentioned that N2 is greater than N1. That means this is basically a high density medium. That means suppose the surrounding medium is air, the lens is made up of glass, not from something else. If it is not glass, then the answer will be different. Now for example, if the ray of light is falling on a convex lens of higher optical density, that is higher refractive index, then they will be focused at the focal length. At focus, they will all the rays will focus, right? So now what is the shape of this line? The shape of this line is basically, if you consider this to be a center, it will be a spherical wavefront, right? So this is a spherical wavefront. So wavefront will be spherical like this, and the correct answer will be option D, not option A or not option B, not option C, but option D. This is the correct answer. So focal length is located somewhere here, right? And all the rays are basically merging towards it. So that is the reason this is the correct answer. Now let's move on to the next question. The total energy carried by light wave when it travels from a rarer to a non-reflecting and non-absorbing medium, it increases, either increases or decreases depending upon the angle of incidence. Decreases, remains same. So total energy of light carried by light when it travels from rarer to denser does not change. Okay, if it is non-absorbent and non-reflecting, so no single amount of energy is neither getting reflected nor being absorbed. So total energy has to be constant, that is the conservation of energy, so it must remain the same. If some part of the energy is absorbed, then it will decrease. If some part of the energy is reflected, then again it will decrease, but energy otherwise will remain same. It cannot increase, and because nothing, no decrease is happening over here, so it should remain same. Next question. In Young's double slit experiment, an electron beam is used to produce interference fringes of width beta 1. Now the electron beam is replaced by beam of protons with the same experimental setup and same speed. The fringe width obtained is beta 2. The correct relation between beta 1 and beta 2. Now this question is not 100% from this chapter. You need to know the concept of dual nature of radiation and doesn't matter, but this question is from this chapter, so you have to study it. Maybe later on, once all the chapters are finished, you can come back to this question and answer it, but you have to remember that fringe width, even though it is not completely part of the syllabus, but still fringe width concepts are still part of the syllabus. Fringe width is proportional to wavelength of light. Fringe width in double slit experiment is directly proportional to the wavelength of light. So if it is proportional to wavelength of light, then what is the relationship between wavelength and that of electron and proton? So electron and proton, they have different masses. Both of them have charges, but charge is not important for this calculation. Only thing that is important is the mass. Now wavelength is directly related to mass. How? Wavelength is given by h by p. This is called de Broglie wavelength. De Broglie wavelength, where p is the momentum of the particle. P is the momentum of the particle. H is called Planck's constant. So momentum is given by mass into velocity. Momentum is given by mass into velocity. So wavelength is basically, from this calculation we can say that wavelength is inversely proportional to mass. Wavelength is inversely proportional to mass. So now if you combine this equation and this equation, we can say that fringe width is inversely proportional to mass, because it's directly proportional. Here it is inversely proportional, so beta must be inversely proportional to mass, right? So beta 1 by beta 2. What is beta 1? Beta 1 is the fringe width due to electron. It must be equals to mass of electron and mass of proton. Okay, inversely proportional. Beta 1 is due to electron and MP is due to proton, beta 2 is due to proton, so they will be inversely proportional, right? So inversely proportional means it will be in the division. So from here we can say that mass of proton is greater than mass of electron. So this quantity, mass of proton divided by mass of electron, must be greater than 1, right? This quantity must be greater than 1. So beta 1 by beta 2 should also be greater than 1, right? If right hand side is greater than 1, left hand side should also be greater than 1, right? So from here we can write beta 1 must be greater than beta 2. So fringe width for electron must be greater than that of proton. So from all of this we can say option D is correct answer. Now next question. 3 Polaroid sheets are coaxially placed as indicated in the diagram. Pass axis of Polaroids 2 and 3 make 30 degree and 90 degree with pass axis of Polaroid of sheet 1. If I0 is the intensity of the incident unpolarized light entering the sheet 1, the intensity of the emergent light through sheet 3 is. So I have solved this question during my lecture, right? Now let's solve it once more. Those who have missed it, I will solve it once more. So I0 is the unpolarized light which is entering the sheet 1. So when an unpolarized light is polarized, its intensity becomes half. So it will be I by 2. So intensity just drops to half. So it will be I0 by 2. Next, it will be cos square 30 degree multiplied by I0 by 2 cos square 30 degree, because it is from Malus law. If you remember, Malus law states that it is I into cos square theta. I is the intensity of light entering the Polaroid and cos square theta is the angle between the previous Polaroid and this Polaroid, right? So from there we can calculate the intensity which is coming out of this. Suppose this is I2. So I2 is given by I0 by 2 cos square 30 degree. Cos square 30 degree. So what is cos 30? Cos 0 is 0. Cos 0 is 1. So 30 means it will be 3 by 2, root 3 by 2, right? So I0 by 2 root 3 by 2 whole square. So there is one way to remember is that if the value is closer to 0, then the next angle will be half. If it is closer to 1, then it will be root 3 by 2. So for example here 0, cos 0 is 1, so cos 30 will be root 3 by 2. cos 45 is half, 1 by root 2, cos 60 which is closer to 0, it will be half, and cos 90 is 0. Okay, this is a trick to remember. So I naught by 2, 3 by 4. Okay, so it will be 3I naught by 8, right? So we have calculated the intensity of light which is coming out of this Polaroid. Now what is the angle between this Polaroid and this Polaroid? This had an angle 30 degree, this had an angle 90 degree. So what is the difference of angle? Difference of angle is 90 minus 30, that is 60 degrees. So what is the final intensity? Final intensity I3 must be equals to I2 into cos square 60 degrees, because both of them are measured with respect to the first Polaroid. Both the angles are measured with respect to the first Polaroid, right? So first Polaroid, this is 30 degree and this is 90 degree, but this angle does not matter. We have to find the angle between these two corresponding Polaroids. This is at 30 degree, so this difference is 60 degrees. So we have to use this formula. So I2 value we have already calculated, 3I naught by 8, cos square 60 means half square, so it will be 3I naught by 8 into 1 by 4, that is 3I naught by 32. So 3I naught by 32, option B is correct answer for this question. Next is, when light propagates through a given homogeneous medium, the velocities of, so when light travels through a given homogeneous medium, the velocities of primary wavefronts are lesser than those of secondary waves. No primary, secondary, they have same speed, right? Primary wavefronts are greater than or equal to those of secondary wavelet. That is also not correct. Primary wavefronts and wavelets are equal. So this is the correct answer. Primary wavefronts are larger than those of the secondary wavelets. That is also not correct. Primary wavefronts and wavelets are equal. So velocities of primary wavefront and wavelets are equal always, right? Now next question. An unpolarized light of intensity I is passed through two Polaroids kept one after another with their planes parallel to each other. The intensity of the light emerging from second Polaroid is 1 by 4. It is not 1 by 4, it will be I by 4. Okay, I by 4. The angle between the pass axis of the Polaroids is. So first we have an unpolarized light of intensity I which is falling on first Polaroid, say P1, and there is another Polaroid. Their planes are parallel, means angle can be different. Okay, planes are parallel, these are also parallel, right? But if I just change the angle, the planes are still parallel, but their axes are not aligned, so axis will be different. So suppose the axis is theta and the final output is I by 4. So what is this angle theta? That we have to calculate. So as we know that when an unpolarized light passes through a Polaroid, its intensity just drops to half. So after first Polaroid it becomes I by 2. So if the angle is theta, then what is the final intensity? Final intensity, say IF, is given by the intermediate intensity I by 2 times cos square theta. Now this value according to the question is given as I by 4, right? So from here we can say that I cancels, 2 cancels, so we get cos square theta equals to 1 by 2, or cos theta equals to 1 by root 2, or theta equals to 45 degrees. Yes, 45 degrees. So correct answer is option D. Option D is the correct answer. Now let's move on to the next question. In case of Fraunhofer diffraction is same as the diffraction that we study. At a single slit, the diffraction pattern on the screen correct for which of the following statement? So let's see. Central dark band is incorrect. Central band is bright band, always in diffraction. Central dark band having alternate dark, central dark band is incorrect. Central bright band having dark bands on either side. Central bright band do not have only black bands, they have alternate black and dark bands, so this is also incorrect. Central bright band having alternate dark and bright bands of decreasing intensity on either side, so option D is correct. So we have seen that in case of diffraction, what happens is that we get a central maxima and then we get a dark, then bright, dark, bright, like that, right? Not only dark, but intensity decreases as you are moving away from the center. So this is the center, and as you are moving up or down, okay, intensity decreases. Okay. Now, next question. When a compact disc CD is illuminated by small source of white light, colored bands are observed. So if you have a CD now, CD used to be very popular when I was at your age. Nowadays CD is almost obsolete. Even pen drives are also not being used anymore, right? We have cloud storages, etc. So but this used to be a phenomenon, and even we used to borrow CDs for watching movies, etc. Nowadays you may have a CD. You can ask your parents that if they have a CD in their library, you can ask them, please show me one, and I hope most of you have seen that as well. So what is a CD? If you put a light on the CD, then you will see some colored pattern. Now this colored pattern is basically due to the bending of light. CD has a very sharp edges on its plane. Okay, that's why it is because of diffraction. It is because of diffraction. So the colorful CD appears because of the diffraction. Whereas if you see soap bubble, when you mix soap into water, you see some bubbles and it appears to be colored. That happens due to interference. So coloring of soap bubble is due to interference, whereas coloring of CD is because of diffraction. For a light diverging from a finite point source, so light diverging from a finite point source, what is the shape of the wavefront? The wavefront is parabolic? No. Even it is a finite, it will still be a spherical wavefront. The wavefront is cylindrical? Obviously not. The intensity at the wavefront does not depend on the distance? No. Intensity do depend on distance. The intensity decreases in proportion to the distance squared. So intensity of light is always inversely proportional to the square of the distance. So if this is the distance, okay, and if you move further away and away, the intensity will decrease with this formula. To be careful. So intensity decreases with the square of the distance. I solved this question during my lecture as well. Now let's continue with the next question. A slit of width A is illuminated by red light of wavelength 600-500 angstrom. If the first diffraction minimum falls at 30 degrees, then the value of A is. Now this formula I have not done in my lecture, but this formula is very important for KCET. So here we have a slit width, and if you observe that, you will see that this thing is called the angular width. This angle is called angular width. The opening of the slit. The slit is opened by small distance. This opening is measured using a small distance A, and wavelength of the light used is obviously lambda. So now there is a relationship. Okay, you have to remember that A sin theta equals to n lambda for bright fringes. For bright fringes, A sin theta equals to n lambda. Now for most practical purposes, and what is theta? Theta is this half angle. For most practical purposes, theta is very, very small. Okay, the value of theta will be very, very small, and because this distance is very large compared to this width, so theta value will be small, and we can approximate this as A into theta equals to n lambda. Okay, because we know that sin theta for small value of theta is equals to theta. Okay, and theta is in radians. Okay, so in this case theta value is not small, 30 degrees is not small. Obviously if theta value is given less than 10 degrees you could have used this approximation, but in this case you have to use the original formula itself. Now a value is not given, a value we are trying to find, so value of a we are trying to find, so a equals to n lambda by sine theta. Now for central maximum n is equals to 1. Okay, so it will be lambda by sine 30. Okay, lambda by sine 30. What is the value of lambda? Lambda is 6500 angstrom. Angstrom means 10 to the power of minus 10. Angstrom means 10 to the power of minus 10. And sine theta value is, sine 30 is half. Sine 30 is half. So value of a will be 2 into 6500 into 10 to the power of minus 10. Now 2 into 6500 is means what? It means 1300. It means 130. 65 into 2 is 130 and 2 more zeros are there as well. Into 10 to the power of minus 10, and unit will be in meters. Obviously, now let's simplify this. So if you can see that answers, if you see that answer, only one answer could be the option, which is this one. None of them has closer to this value 1300, right? So what we have to do, we have to find 1.3 and check the 10 to the power. So 1.3 means 1, 2, 3, 4. So 4 zeros we have to reduce. So a equals to 1.3 into 10 to the power of minus 6. So we have taken this 1, 2, 3, 4 zeros and reduced it from this minus value. So it will be minus 6, and minus 6 means micrometer. Minus 6 means micro, right? So 1.3 micrometer, and in sometimes micrometer is also called microns. So correct answer is B, 1.3 microns. Now next question, which of the statements are correct with reference to single slit diffraction pattern? Let's see. Fringes are of unequal width. So as we know that fringes are unequal width, the central maximum is the brightest and the largest. Others are not as big as the central maximum. So fringes are of unequal width. Fringes are of equal width, obviously not correct. Light energy is conserved. So light energy do conserved in case of diffraction or in interference. Intensities of all bright fringes are equal. No central bright fringe is maximum in brightness, and as you are moving away from the central brightness, the intensity decreases. So only 1 and 3 are correct. So option A, 1 and 3 are correct. Now let's move on to the next question. This is slightly tricky question. In Young's double slit experiment, a monochromatic source of wavelength lambda is used. The intensity of light passing through each slit is I0. The intensity of the light reaching the screen SC at point P, a distance x from O, is given by text D is very, very smaller than D. So here is the diagram. As you can see, the slit distance is very small compared to the distance capital D, and here the total distance from the central maximum is given, which is given as x, right? This angle is given as theta. Now you can what is the formula for intensity? Formula for intensity is given by I equals to 4I0 cos square phi by 2. If you remember, this is the formula. Phi is the phase difference. Now if you want to solve this question, you have to remember a formula which is slightly out of the syllabus, but remember that this problem could easily be solved with a longer and tedious geometric method as well. Okay, so there is a legitimate way which is part of the syllabus using some longer method, but I am going to teach you something which is very, very short, but here the formula that I am going to use is not directly part of the syllabus. What formula I am talking about? So phi is given by 2 pi by beta into x. Okay, so phi is 2 pi by beta into x. This formula you have to remember. Okay, beta's direct formula is not part of the syllabus, that's why I am saying this is the formula I am using. So what is the formula for beta? Lambda into capital D by small d. Okay, those who are preparing for JEE, anyway you have to remember this formula, it is part of the JEE syllabus. So phi becomes 2 pi into d by lambda capital D into x. Okay, so this is phi. So what is phi by 2? So phi by 2 is, this 2 will be cancelled and you get pi d by lambda d into x. Okay, so just put this value, it will be 4I naught cos square pi d by lambda d into x. So this is the formula for intensity at any point on Young's double slit experiment. So let's go back to the equation. So 4I naught cos square pi d by lambda d into x. So correct answer is this one, option B. Okay, now next question, 3 Polaroid sheets. So this type of questions, as you can see, is repeatedly coming year after year. Last year it did not came, but almost every other year you will see one such question is coming year after year. 3 Polaroid sheets P1, P2 and P3 are kept parallel to each other such that the angle between the pass axis of P1 and P2 is at 45 degrees and that between P2 and P3 is also 45 degrees. If unpolarized beam of light of intensity 128 watt per meter square is incident on P1, what is the intensity of the light coming out of P3? So here we have 3 Polaroids, 1, 2, 3. So angle between this is P1, this is P2, this is P3. Okay, so angle between P1 and P2 is 45 and angle between P2 and P3 is also 45. Okay, now the light which is entering, say intensity I. Okay, and we know that as soon as it passes through the first Polaroid, it becomes polarized and its intensity becomes I naught by I by 2, right? What is the intensity after it passes through the second Polaroid? So second Polaroid intensity will be I2 equals to I by 2 cos square 45 degrees. So cos 45 means 1 by root 2 whole square. So it will be I by 2 into half, that is I by 4, right? Now when it passes through the third Polaroid, what will be the intensity? It will be I3 equals to I2 into cos square 45. So cos square 45 we already know it is half, I2 we know is I by 4, so I by 4 into half, that is I by 8. Now what is the value of I? I value is given in the question 128. So 128 divided by 8. So it will be 64 by 4 or 16. So it will be 16 watt. Okay, 16 watt per meter square. Okay, correct answer is option A. Now next question. In Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of the light at a point on the screen where path difference is lambda is k units. The intensity of the light at a point where path difference is lambda by 3. Now here you have to remember the original formula, that is I equals to 4I naught cos square phi by 2. Right, this was the original formula. Now what is phi? Phi is 2 pi by lambda into delta x. What is the difference between this equation and the beta equation? Here it is in terms of delta x, which is the path difference, right? And that equation was in terms of x, that is the distance from the central maximum, and that equation was only valid for d very smaller than capital D. This equation is common, it is valid for all cases. Now here it is given that when the path difference is lambda, so what is the value of phi? So first case number 1. So for case number 1, the path difference is lambda, so what will be the phi? Phi will be 2 pi by lambda into lambda, so it will be 2 pi. Okay, so phi by 2 is pi. Phi by 2 is pi. So what is the first intensity, which is given as K? So intensity K is basically 4I naught cos square pi. Right? Now cos pi is minus 1. Cos pi means cos 180 degrees, so cos 180 degrees is minus 1, and minus 1 whole square is basically plus 1. So from here we get K equals to 4I naught. So from this equation now we can write this as K into cos square phi by 2, because 4I naught itself is equals to K. Right? Now the second case, now let's go back to the second case. Second case, it states that the path difference delta x is lambda by 3. Right? So what will be the phase difference? So phase difference will be 2 pi by lambda into lambda by 3. Okay, which is equals to lambda cancels and you get 2 pi by 3. Right? So what is phi by 2? Phi by 2 will be pi by 3. Okay, these two will be coming over here, so pi by 3. So pi by 3 means what? Pi by 3 means 60 degrees. If you are wondering, pi by 3 means 60 degrees. Now let's put that value over here. So what will be the new intensity? So the new intensity will be K into cos square 60 degrees. Cos 60 means half, so cos square 60 means 1 by 4. So it will be K by 4. Okay, so correct answer is K by 4. Option D is correct answer. Follow methods, follow step-by-step process, and you will be solved all the questions very quickly. A plane wavefront of wavelength lambda is incident on a single slit of width A. The angular width of the principal maximum is. So I already shared the formula for small angle A into theta equals to n lambda. For central maximum it is equals to lambda. So half of the angular width is lambda by A. Why half? If you remember the diagram I have drawn, that this is the screen, this is the width, and here is the angle theta. Right? So this is the maximum, central maximum. This is called half angular width. So full angular width will be 2 theta. Right? So what is the full angular width? Full angular width will be 2 theta, which is 2 lambda by A. So this is the full angular width, 2 lambda by A. Correct answer option B. Now next question. In Fraunhofer diffraction at a single slit, if yellow light is illuminating the slit, it is replaced by blue light. Then the diffraction bands, so angular width of a diffraction band, if you remember, is given by 2 lambda by A. Now A is constant because same slit is used, right? Now for blue light, the wavelength of blue is less than that of wavelength of yellow. Okay, red light has highest wavelength and violet light has smallest wavelength in the visible region, right? If you remember VGR that you have studied in your previous class. Now blue is closer to violet, so blue has lower wavelength compared to that of the yellow. Yellow comes in exactly in the middle of the band, right? Yellow is exactly middle between violet and red, whereas blue is closer to violet. That's why the wavelength of blue is smaller than that of the yellow. So width of blue will be smaller compared to that of yellow. Now you are using yellow, changed to blue. So blue is the new one, so the bandwidth will be narrower. The bandwidth will be narrower. It will become narrower. Narrower means smaller value. Okay, narrower means smaller value. So for yellow light, suppose the bandwidth was like this, but for blue light, the bandwidth will be like this. So narrower means the length decreases, right? This is for blue, and this is for yellow. Right? So bandwidth decreases. Next question. In Young's double slit experiment, two wavelengths lambda 1 equals to 780 nanometer and lambda 2 equals to 520 nanometers are used to obtain interference fringes. If the nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda 2, then the value of n is, again I have solved this question in my lecture, if you missed it, let's solve it once more. So x, that is the position of any bright band, is given by n lambda capital D by small d. This is the position of the nth bright band on the screen, okay, from the central maximum. Now if this is due to first light, so this is lambda 1 x1, and for second light it will be n plus 1, because it is n plus 1th, right? So it will be n plus 1 lambda 2 d by d. Now what is the meaning of coinciding? Coinciding means whatever is the value of x1, same is the value of x2. So if x1 equals to x2, then we say they are coinciding, right? So if I am standing over here, if someone is standing exactly at this place, we will say that me and this floor is coinciding, right? So this is what it means coinciding. Coinciding means 2 points located exactly at same location, right? So n into lambda 1 d by d equals to n plus 1 lambda 2 d by d. Obviously d cancels, and we get n lambda 1 equals to n plus 1 lambda 2. Now let's put the values over here. So what is, let me use this space, this is slightly bigger. So what is n1? N we don't know, we have to find the value of n. What is lambda 1? Lambda 1 is 780 nanometer. What is lambda 2? Lambda 2 is 520 nanometer. Nanometer gets cancelled. Now let's cancel these zeros, and we get 26 52. It will be 39s are 78. So it will be 3 13s are 39, 2 13s are 16. So 13 cancel. So you get 3n equals to 2 into n plus 2, or 3n minus 2n equals to 2. So just break this out, 2n plus 2, and bring this 2n on this left hand side. So from there you get n equals to 2. So the value of n must be equals to 2. So correct answer option C. Next question. In Young's double slit experiment, slits are separated by 2 mm and the screen is placed at a distance of 1.2 meter from the slits. Light consisting of two wavelengths 6500 angstrom and 5200 angstrom are used to obtain interference fringes. Then the separation between the fourth bright fringes of the two different patterns produced by the two wavelength is. So what is the position of the fourth bright fringe for the first case? Okay, it is given by n lambda d by d. Fourth bright fringe, okay, lambda for the first one is 6500 into 10. Now in this case you have to, there is no other option, you have to use the value. Okay, so x4 is given by 4 into 6500 into 10 to the power of minus 10. D value is given as 1.2 meter and small d value is given as 2 millimeter. 2 millimeter means 2 into 10 to the power of minus 3. Okay, so 2 cancels, 2 to the 4. Now 31 3 is double 000 into 1.2 into 10 to the power of minus 7, right? So from here we can write 1 2 3 4. So 1.3 into 1.2 into 10 to the power of minus 3. Okay, or it will be 1.69 minus 13, that will be 1.56. Now how to multiply this? 13, suppose how to multiply this? There are two ways to do it. Okay, this comes under Vedic math. So if you are interested, you can follow Ankit sir. He is doing a wonderful job there. Now 13 into 12, how to multiply it? So first method is the method that I have used. I have made it 13 into 13. Okay, but 13 into 13 is obviously not correct. So what I have to do, I have to minus another 13. Okay, so if you take 13 common, it will just become 13 into 12. So 13 into 13 answer we know it is 169. Okay, square number. So it will minus 13, you have to do minus 13 will be 156. Okay, if you don't remember the table, this is the easier way to remember exact value. Okay, now so this is how you can calculate. Let us continue with the x4 for the second light, that is 5200 angstrom. So x4 will be again 4 into 5200 into 1.2 into 10 to the power of minus 10 divided by 2 into 10 to the power of minus 3. So 2 again cancels. Now what you get? You get 104. 2 into 52 is 104, and then we have two zeros, into 1.2 into 10 to the power of minus 7. Minus 3 plus 10, minus 10 plus 3, it will go up and become plus, that's why it is minus 10. It will be 1.04 1234 into 1.2 into 10 to the power of minus 3. Now this can be approximated, very small approximation, that we can assume that 1.04 is very close to 1. Okay, so this is an approximation method. So from here we can approximate x4 dash to be 1.2 into 10 to the power of minus 3. Okay, so 1.2 into 10 to the power of minus 3. So what is the difference between these two? What is the difference between x4s? So x4 minus x4 dash, that is 1.56 minus 1.2 millimeter. So 10 to the power of minus 3 means what? 10 to the power of minus 3 means millimeters, right? So from here you can get almost equals to 0.36 millimeter. Let's see which answer is closest to this. So only one answer is very close, which is this one. Okay, only one answer is close, this is this one, 0.312 millimeter. So if you multiply this exact value and calculate it, you will get 0.312 and not 0.36. 0.36 is my approximated value. Then you have to check the closest answer, and in KCET generally, even if you do approximation, your final answer, you will always find that final answer, your answer will get to match with one of the given options, right? Next question. In a system of two crossed polarizers, it is found that the intensity of the light from the second polarizer is half from that of the first polarizer. The angle between their pass axis is. So we have two crossed polarizer. Okay, one is this. So suppose the intensity of light is I from here, it is found to be I by 2. So what is the angle between these two polarizer that we have to calculate? Now from Malus law, we know that final intensity is given by the original intensity times cos square theta. Now this value is already given half of that, so that means it will be I by 2. So cos square theta must be equals to half, or cos theta must be equals to 1 by root 2, or theta must be equals to 45 degrees. So correct answer is 45 degrees, option C. Now next question. According to Huygens principle, during refraction of light from air to denser medium, wavelength and speed increase, wavelength decreases, speed increases, wavelength and speed decrease, wavelength increases, speed decreases. Now you have to remember that Huygens principle is will always follow the standard speed of light, right? And we know that when light enters from rarer to a denser medium, its speed decreases. Okay, its speed decreases as speed of light is maximum in vacuum, and in any other medium speed of light is less than that value. Speed of light cannot increase, it is a cosmological constant, right? So speed of light, whenever it is entering a denser medium, its speed will always decrease. And there is one more relation, V is equal to f lambda. F is frequency of wave and lambda is the wavelength. Now frequency of light is constant. No matter what is the medium, frequency of light will always remain constant. Okay, so this is constant. Now V value is decreasing. So V value is decreasing, speed of light is decreasing. So lambda must decrease as well. Lambda must decrease as well. So wavelength and speed both will decrease. So when light enters from rarer to denser, speed and wavelength decreases. When light enters from denser to rarer medium, speed and wavelength both increases, right? Now let's continue with the next question. In Young's double slit experiment, the source is white light, one slit is covered with red filter and other with blue filter. There shall be, now you have to understand that Young's double slit experiment can be observed when monochromatic sources of light is used. Okay, monochromatic sources of light is used. So blue and yellow are two different colors. That means you will not, blue and red are two different colors, two different primary colors in fact. So that means you will not get any fringes. You will not get any fringes because monochromatic light is required. Now in some cases, if you are using mixed colors, there will be some fringes, but that will be slightly tricky and difficult to predict. If you are using white light, then central fringe will be white. Okay, central maximum will be white and then there will be some colored fringes, and lastly there will be only white left in the throughout the screen, right? There will be no particular dark fringes, but central bright, then some colored fringes, and then white again. That's how you are expected in case of white light. Light of wavelength 600 nanometer is incident normally on a slit of width 0.2 millimeter. The angular width of the central maximum in diffraction pattern is, so angular width in diffraction pattern is given by 2 theta equals to 2 lambda by A. This is the total angular width. So what is total angular width? So 2 into what is the wavelength given? The wavelength is 600 nanometers. 600 means 600 into 10 to the power of minus 9. What is the slit width? Slit width is 0.2 millimeter. 0.2 means 0.2 into 10 to the power of minus 3. Okay, 0.2 into 10 to the power of minus 3, or you can take this decimal out. You can take this decimal out, 2 into 600 into 10 to the power of minus 9, and you can take this decimal out and make it 10 to the power of minus 4, right? Decimal means 10 to the power of minus 4. So 2 cancels and we get this as 600 into 10 to the power of minus 5. 600 into 10 to the power of minus 5, or 6 into 10 to the power of minus 3 radian. Now remember, this formula is only valid when the angle is expressed in radians. So sin theta nearly equals to theta is only when theta is in radians, not in degrees. Now fortunately all the options are given in radians, so you can correctly identify it, but in case the option is slightly tricky when degrees are also mixed, then you have to be careful. Sin theta equals to theta is only valid when theta is expressed in radians. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is the wavelength, should be of the order of the wavelength, has no relation with the wavelength, should be much larger than wavelength. So you have to remember that the diffraction pattern is only observable, not only diffraction, interference as well. It is only observable when the slit width is comparable to that of the wavelength. So it may be 1 lambda, 2 lambda, 3 lambda, 5 lambda, 10 lambda, but should not be 100 lambda or 1000 lambda. Comparable means it obviously should be more than lambda, but closer to lambda value. Okay, but 10 lambda, 20 lambda is still fine. okay, but it should not be so super large, it should not be smaller than that of the wavelength as well. A polarized light of intensity I naught is passed through another polarizer whose pass axis makes an angle 60 degree with the pass axis of the former. Okay. What is the intensity of the emergent light of the polarizer? Now this question I am leaving it to you as a homework question. Why? I have already solved so many questions on this topic, and this is the most easiest question from this out of all the questions, and this is from KCET 2014. So as you can see, almost 10 years this question based on Malus law is coming, except last year almost every year there was one question from Malus law. So please try to answer this question and mention the answer in the comment section of this video. I'll try and reply to your comment if you are answering it. And this is the last question from this chapter. Some questions from this chapter are deleted, so that's why I have not covered them in my discussion. For example, some direct fringe width related questions, some questions related to Doppler effect of light and Rayleigh scattering, those are no longer part of the syllabus. So because I have not covered them, that means they are not part of the syllabus, so you can easily skip them. And here is the toppers that came to our office and met us. So if you are following our lectures regularly, then definitely I hope to meet you sometime very soon. I will be back with new lecture very soon. Till then, bye.